Good day everyone. For today's topic, we will discuss to you Lesson 5, Dynamic Routing, Topic 2, RIPv2. First, router RIP configuration mode. As you can see, may tatlong picture dyan sa gilid. First, use the router RIP command to enable RIPv1. Number 2, use the number router RIP command to disable. Advertise network. The network address router configuration mode command. Number 1, enables RIP on all interfaces that belong to a specific network. Second, advertises the network and RIP routing updates sent to the router every 30 seconds. May dalawang picture po dyan. Yung una, verify RIP routing. Sunod, show IP protocols. Displays IPv4 routing protocols configured on the router. Next slides. Show IP route displays RIP routes installed in a routing table. Yun po. Next, enable and verify RIPv2. First, use the version 2 router configuration mode command to enable RIPv2. Next, use the show protocol command to verify that RIPv2 is configured. Third, IP route command to verify the RIPv2. Then, next, use the number auto summary router configuration mode command to disable auto summarization. And last, use the show routing table. Yung nakikita nyo po dyan sa yung picture sa gilid.
Then next is disable auto summarization. First is RIPv2 automatically summarize networks at major network boundaries. Second, use the show IP protocols command to verify that auto summarization. Then the next is configure passive interface. RIP updates and forwarded out all RIP enable interface by default. First is only need to be sent out interface that are. Then second, connected to other RIP enable routers. Then third is sending RIP update to LAN, ways bound with waste resources and is a security risk. Then next is use the passive interface router configuration command to stop routing updates. Out the interface is still allowed that the network to be advertised to the other router. And then propagate a difficult route. In a diagram, a difficult static route to the internet is configured on R1. Then next is the difficult information originate route configure command instruct R1 to send the difficult static route information in the RIP.
Hey everyone, this is the report of Group 3, Dynamic Routing. I will be the one who discuss dynamic routing protocols. My name is Iverson Elias. First of all, what is dynamic routing protocols? Dynamic routing is where a protocol residing inside of a router automatically creates and updates a dynamic routing table. Essentially, a routing protocol helps to exchange routing data between multiple users. This data is used to build a routing table that details the best path for the traffic to take. In dynamic routing protocols, RIP or RIP protocol was updated to RIP or RIP version 2 to accommodate growth in the network environment. RIP or RIP version 2 does not scale to current larger. Routing protocols developed to meet the need of larger networks include Open the Shortest Path First or OSPF enhanced IGRP or EIGRP, intermediate system to intermediate system or ISIS. Border Gateway Protocol or BGP is used between Internet Service Providers or ISPs. Dynamic Routing Protocols components. The purpose of dynamic routing protocols is to discovery of remote networks, maintaining up-to-date or update routing information, choosing the best path to destinations networks, ability to find a new best path if the current path is no longer available. The components of dynamic routing protocols is data structure. Data structures or tables are database, keep it in RAM, or routing protocol message. Discover neighboring routers, exchanging routers information, and maintain accurate information about the network. The second is algorithm. To facilitate learning routing information and for the best path determination. Dynamic versus static routing. In static routing uses, network often use both static and dynamic routing. Static routing is used as follows for easy routing table. Maintenance is small network. Routing to and from a stub network. Accessing a single default route. Dynamic routing protocols uses the best choice for large networks. Dynamic routing protocols helps the network administrator manage the network, providing redundant paths, automatically implementing the alternate path when a link goes down. So that's it for the topic 1.
So we are now here in the topic 3 routing table presented by myself, Mariano Adonis Jr. and my partner Magna Jr. So let's start. Topic 3 routing table. So we are going to talk about the parts of IPv4 route table entry. So as you can see here in the picture in the bottom right, so that is the example of sorry for that noise. That is the example of a routing table for R1, R version 1. Directly connected entries. So directly connected networks are automatically added to the routing table when the interface is configured and activated. Entries contain the following information. So here yung entries na yung entries na ating kinonfigure ay directly na ma-add dun sa ating routing table. So tingnan na lang natin yung table sa baba at makikita nyo dyan yung parts ng ating routing table. As you can see there, meron siyang route source. So ang route source, how the route was learned, yun yung kanyang purpose. Destination network or the remote network. Sunod naman sa huli ay yung outgoing interface, exit interface used to forward packets to destination. So meron din naman tayong ibang route source entries sa ating routing table. Included dun yung static route or the S symbol and the D symbol is EIGRP routing protocol, and sunod naman yung OSPF routing protocol and the R or the RIP routing protocol. So yeah, just take a look in the diagram on the bottom right side. So there's a legend there. The green color, which is route source, identifies how the network was learned by the router, and the middle table is the destination network, identifies the destination network and how is it is connected. And also the third is the orange color identifies the interface on the routing connected to the destination network. So next slide. Remote network entries. Routes to remote networks contain the following information. Route source. So yun ang kaninang sinabi ko. Isa-isa lang po natin ito. So isa-isahin natin yung laman ng ating routing table. So una, route source, how route was learned. Sunod naman ang destination network or administrative distance, AD, trustworthiness of the route. Kumbaga, nandyan yung tawag dito on how it is correct and authenticated, parang walang breach sa security. So sunod naman, metric, value assigned to reach the remote network sa metric. So tingnan natin doon sa may sa may diagram po natin sa upper right ng ating slide. Kita natin dyan yung destination, yung route source, destination network. Sunod ay administrative distance. Sunod ay yung metric. And also lower is better on next hop. IPv4 address of the next router that the packet should be forwarded to. So sa next hop. Yan. Sunod naman yung route timestamp. Time since the route was updated. So kailan siya nag-update or anong oras or yung update niya. Yun yung route timestamp. Sunod naman, outgoing interface, the exit interface to use to forward the packet. So yan, the outgoing interface. Next, dynamically learned IPv4 routes. So as you can see here, we have a diagram here. Makikita nyo dun sa upper right picture natin dyan ay yan yung example ng ating routing table na kung saan ay makikita nyo yung route source, yung dynamic network at yung outgoing network. So makikita nyo dyan. For example, this one yung sa pang-apat are route source 172.16.2.0/4. So dyan yung ating destination network. Sunod naman yung metric natin and the administrative distance 120 and over 1. So sunod naman yung ating next hop natin sa pang-apat na kung nasusundan nyo ako, pang-apat via 209.165.200.226. Ayan. So yun yung next hub natin, yung pagsisendan niya. And also the timestamp 12 and the outgoing interface is serial 10/0/0. So that's the example of the our routing table for R1. So the hierarchy includes ultimate routes, level 1 routes, level 1 parent routes, level 2 child routes, and the ultimate route. An ultimate route is a routing table entry that contains either a next hop, IPv4 address, or an exit, directly connected, dynamically learned, and local interface. So that's all for my topic. The other topic will be presented by Mr. Magno. The level 1 of a routing table. Okay, that's all. Thank you.
Good morning, sir. This is my report. Lesson 5, Dynamic Routing. My report is the routing table, Dynamic Learn IPv4 routes. Level 1 Parent Route. A parent route is a level 1 network route that is subnetted. In the routing table, it is basically provides a heading for the specific subnets it contains. So, we have something called a level 1 parent route, and this can be described as some sort of headline, something that we set up or we can see in our routing table. If we have done subnetting, for instance, here we have the ones 72 1600 slash 16 is variably submitted into 5 different subnets with 3 different masks. So this is just the headline. This has no exit interface. It has no next stop, so we cannot send something to this line. So this is for these two networks. In this case, here we can see that this is just, to tell us that we have done some subnetting with these two network addresses. So parent level 1 level 1 parent route is just something that tells us that there is a subnet going on. Then the child route, the level 2 child route is of course the child for the parent route. Level 2 child route. A level 2 child route is a route that is a subnet of classful network address. Level 1 parent routes contain level 2 child routes. Level 2 child routes are also ultimate routes. The child route, or the level 2 child route, it is of course the child for the parents, which means that this tells us how we have done in the subnetting. So this will tell us if I have the parent route, tell me that I have 5 different subnets. Well, then if I have 5 different childhoods with which will tell us exactly which subnets do I have on which interface, or in with which next hop route. Yeah, so it will tell me how this subnet actually done. And you can see here that the shell road also have an exit interface or a next hop route. So what happens when I get something in is that I try to find out, but when I have an IP address, I get a package with an IP address. I look at the network, part of the IPRS, and then I start looking into my writing table. So if I have a match on my level, one ultimate route, well, then this is used. If I don't, well, then I it will try to find out with a parent route, because it will look at this IPS submitted it anyhow, and if I have, then it will go to the child route and then try to find the best match with my submitted routes. If there is a match, well, then it of course will send it out on this interface, and there is not a match, well, then it will go to the next step which is try to find out whether it is summarized route that has a match on this one. If not, it will go and look at is there a default route, because basically default route it will almost always match. And if there is no match at all, then in the end it will drop the packet. So the best route is the longest match. So if I have an IP address 172.160.10, then it will look at my different routes in my routing protocol or routing table and find out what is the longest match for this destination. And it will choose the one with the longest match with most corresponding bit. Yeah, and when we look at it in an IP version 6 perspective, the things that actually become a little easier because we don't really submit so all IPv6 entries, and our ultimate routes, we don't have any level 1 parent or level 2 child routes in IPv6. So example, here of an IPv6 routing entry, then we will see here again if I have a C in front or if it has a directly connected network. So we will see that the add, and we will see the metric and the outgoing interface on for instance here, and route will then again we will see where it come from the destination network. We will see the add, which is the case in 90. We will see the metric and next hop and the outgoing interface, and that was it. Thank you.